Bismillahirrahmanirrahim. So the discussion for today's session is about acceleration. If you're talking about the syllabus for a Khan University Examination Board or for those schools which have been affiliated with AKUB, so this lecture will provide the children with the basic of acceleration in detail. Now, one thing which is very important in this lecture is that this lecture is based on the SLO number 1 and SLO number 2, which I am going to share with you people in the description. So you can cover the first two SLOs of AKUB syllabus for prep 9th of physics. Okay, if you're talking about acceleration, one thing which is very common to us is about the accelerator of a vehicle or of a motorbike. But why we are saying this as accelerator? Okay, so is there any relationship between acceleration and the accelerator of a vehicle? So let us discuss acceleration in detail, then we will relate these two with each other. If we are talking about acceleration, acceleration is a vector quantity that is defined as the rate at which an object changes its velocity. An object is accelerating if it is changing its velocity, and the unit of acceleration is meter per second square. So if we are talking about acceleration, so this is the measure of change in velocity. Measure of change in velocity means that if the velocity is changing with respect to time, then we can say that there is some acceleration. Now, as we know about the time rate or rate at which rate means that acceleration is producing due to the change in the velocity of an object with the passage of some time. So there are a lot of definitions of acceleration. So as in front of your screen, the definition is given, as well as you can define as time rate of change in velocity is also called acceleration. And SI unit of acceleration, as we discussed here, is that meter per second square. We are talking about the mathematical formula. Mathematical formula of acceleration is just look here, change in velocity divided by time. Now, which means that acceleration is equal to change in velocity means final velocity minus initial velocity. So there are two velocities here, one is the final velocity, another is the initial velocity, and divide by time. And remember one thing, that acceleration is directly proportional to the velocity change and inversely proportional to the time required to change the velocity. Now if you're talking about a scenario here which have been discussed here in this handout, sports announcer will occasionally say that a person is accelerating if he or she is moving fast. You know about this scenario here. Now, for example, about this scenario, we have a table here. Time, we have, just look here, 0 second velocity, 0 meter per second. Is there any acceleration? No, because the velocity is not changing, neither we have a time here, so we don't have any acceleration. Then for the first 5 seconds, sorry, for the first 1 second, we have the velocity 10 meter per second. Then 2 second, we have 20 meter per second. Then 3 second, 30 meter per second. Now just look here, what is the difference between these velocities? 0, 10, 20, 30, 40 and 50, which means that the velocity is not changing with respect to time. Now just look here, 0 and 0, 1 and 10, 2 and 20, which means that there is an interval of 10 meter per second velocity there, due to which you can say that we don't have any acceleration there. So this is a scenario which we are discussing here, which have been given in this paragraph, which I am going to just highlight for you people here. So according to this scenario, we have discussed this table for you people. Now what will be the example of acceleration in our daily life? So there are different examples. An object was moving north at 10 meter per second, and apple is falling down. Now this is about the apple is falling down, this is about to the free fall. Now Jane is walking east at 3 kilometers per hour. Tom was walking east at 3 kilometers per hour. Sally was walking east at 3 kilometers per hour. Acceleration is due to gravity, yes, which we discussed in the free fall. The car turning at a corner is an example of acceleration because the direction is changing. The quicker the turns, the greater the acceleration. So remember one thing, that acceleration does not depends upon the change in velocity only. It produced due to the change in direction as well. If we are talking about what we call say the uniform circular motion. So in uniform circular motion, since we are using uniform circular motion, so the velocity is uniform there, which means that it is not changing. So why there is a centripetal acceleration there? So it is due to the continuous change in the direction of the motion there. So if you're talking about the car turning at a corner, it's also an example. If a boy is running with a constant velocity or uniform velocity, but if he is changing the direction, this means that there will be some acceleration produced. So for acceleration, you should remember a few things here. First thing is that time rate of change of velocity is known as acceleration. The second thing is that if you are talking about the acceleration there, so the second thing is about the change in velocity with respect to time. Then we have change in direction, whatever, if we are talking about any different scenarios here. So if acceleration is producing there, so there would be two cases: direction is changing or velocity is changing, or one of the direction or velocity is changing there. So, and this is totally related to the first two SLOs of the topic acceleration there. So if you're talking about the further description of mathematical forms there, so we will put all these in the next